Hello everyone, my name's Jakub Fiala and I work in BBC Research and Development in London. And today I want to talk to you about R-Audio, which is a library of React components for building web audio graphs. It's a kind of side project of mine. Now, today I'm not going to give you an introduction to web audio because you all know it, but I'm going to tell you a bit about my motivation for writing this library. I'm going to talk about some of the other projects that have inspired me, give you an overview of the actual library, and talk about some of the design issues I faced when I built it. And hopefully there will be time for some code examples and demo. Right, so let's just skip this all. Web audio is amazing, we all love it. All right, cool. So, first of all, the web audio API is, and some of you might contest me on this, but I basically believe that it's fundamentally an imperative API where, you know, it's very explicit in every single thing you do. So this is a standard kind of snippet of web audio code where you're creating buffer stores and then you have two delay lines with different parameters. So, you know, as you can see, there's a lot of method calling. We call a method for every single node we create. We bind it to a variable. We wouldn't necessarily have to do that. We could create an array or something like that. We have other ways of storing it, but it's up to us to store references to those variables. And similarly, when creating connections, we actually call this connect method for every single connection, every single time. And anytime we want to change anything, we have to call it again. So just zoom out, come back to the presentation. So this is not a criticism of the API in any sense. I really like it, but I think there are some issues with it, especially when you're trying to create large web audio applications with huge graphs. So if you have lots of nodes, you end up with loads of variable bindings, you know, or it's basically up to you to keep that state. You always have explicit connections, and anytime you mutate the graph, let's say you have a component that's connected, a node that's connected to 50 other nodes, when you remove it from the graph, you have to re-establish all those connections manually. And also, if you look at if you remember the code that I just showed you, you wouldn't, by just glancing at the code, you wouldn't necessarily be able to tell that there's two cyclical loops in it, but there actually are. And the last thing is we don't really have a standard way yet of creating kind of reusable modules, although as we saw there's a lot of efforts going on in this area. So some of the projects that have inspired me, libraries like A-Frame and React, they both rely on this idea of explicit and implicit state. So you have a virtual explicit state that's controlled by the developer, and then the library then reconciles that state with what I call implicit state, which is either your DOM or, in the case of A-Frame, a WebGL context. So in the web audio world, there are some projects such as HTML Web Audio Elements. This was featured at a previous web audio conference. And these are basically based on HTML custom elements. You don't need to create connections implicitly, but there is a bit of a limited API coverage. And the other thing is that to create connections between nodes, you basically use this kind of parent-child relationship. But what if I wanted to connect that by-quad filter to a completely different source or a different node somewhere else? I don't have a way to do that. Virtual Audio Graph is a library that actually maintains its virtual representation of the graph, and then you have this update method. So that's really helpful. You create your graph with a plain JavaScript object, and then you can pass around the numeric IDs of individual nodes to connect them. But that's actually explicit, so it's not actually that different from just calling the connect method. React-webaudio is similar to my library in the sense that it's based on React. But there is, again, that problem of nesting. This is actually a code example from the README, and this is a single kind of series of nodes connected together. The API coverage isn't that good as from what I can tell either. And an interesting last example is React Music, which is a kind of higher level library, and they have an interesting way of doing kind of routing with the idea of buses. So you create a bus, put some effects in it, and then you can send different instruments to it, which is quite interesting. Right, so what can I do to kind of, so my goals with this library were essentially to make creating audio graphs more possible to work in React, or easier to work in React, make the graphs more readable and more inferable from the code itself, and also have the ability to have reusable subgraphs, easier state management if possible, and also this idea of like, could we have the React UI, the UI parts of our React code be bundled together with the WebAudio parts. So why did I choose React? Mainly because React components are inherently modular, reusable, and shareable. There is the declarative JSX syntax. You have a virtual DOM out of the box. And there is this idea of unidirectional data bindings. So you have a kind of central source of state, and then the rest of your application is kind of flows through it. And that's really helpful if you have a large application with a lot of data that's then creating a graph. And also, it's a very popular framework with front-end developers and web developers in general. So I thought it'd be useful to have a WebAudio wrapper for it. Right, so I'm not going to go into great detail into this because I don't have a lot of time. But essentially, the way I did this is I had this kind of object-oriented architecture where you have audio nodes, which are actually just mirrors of the WebAudio API, even with their properties mapped to the audio params, and the concept of graph nodes, which actually don't create any audio, but they help you create your graph in different ways. So what does that look like? So I'm going to show you a snippet, which does the exact same thing as the previous native WebAudio snippet, but in JSX. So you can see that we just basically declare all our WebAudio nodes, but then there are all these funky components around them, and they define how the graph is composed. So these components can be, sorry, it's really hard to zoom out. There are 4 graph components. You have the R pipeline, which takes all its children, connects them in a series. R split takes all its children and basically connects them in parallel. R cycle connects every child to itself, as well as the output of the R cycle. And this is a good example. So R split channels is actually a compound graph component. So the beauty of this architecture is you can compose these components to create weird graphs. So here we're using a channel splitter and a channel merger to essentially have a component that distributes its children between the various channels. Our audio currently is open source, and it supports all non-deprecated nodes, including the audio worklet. There are a couple of methods I haven't had time to add in yet. And the one thing that you can do as well is you can actually put bits of HTML in these graphs. So you can do the thing on the top where the audio context actually has access to all the audio things inside. But if you did the thing on the bottom, the context would have no way of actually reaching that buffer source, although the buffer source can reach up to its context. Right, so some of the issues I've faced. The first thing is, with WebAudio nodes, you have the distinction between connectable and non-connectable ones. So let's say I want to connect these 4 nodes in a pipeline. Obviously, that filter won't be able to connect to the oscillator. So essentially, there's a kind of algorithm that resolves the pipeline one by one. And if it reaches a non-connectable node, it will create an inbound branch like this. When you mutate graphs, React has these so-called lifecycle methods, which means that every component has hooks for when it's added to the DOM, before it's being removed, and at different points in its lifecycle. So we can use those to proactively connect and disconnect the internal node from wherever it's connected. And the way we do this is that the graph components will give their children a destination and a parent function. And so the destination function would essentially return all the audio nodes that this particular node is connected to, and vice versa with the parent function. With scheduling, this is interesting because, again, we don't want to have direct access to the audio node objects. So we just use React props, which are just basically parameters. So what you would do is you would basically create a buffer source and say start at time 0. And if you do that, it will actually start playing. If you don't pass the prop, it will just sit there. It will be connected, but it won't start playing. Audio parameters, again, you're just passing props such as frequency and gain, and then you have these props to do it for doing transitions. That's not maybe the most flexible system, but it's suited for most applications, I would say. The one point of contention that I had with the HTML, the custom elements library that I mentioned earlier, is that you actually included your buffers as parts of the declarative syntax. And I just don't think that that makes a lot of sense because they're not actually part of the graph. So they kind of break that intuition of what I'm looking at, this kind of XML-like syntax is actually a direct representation of what I'm going to hear. So what we do is we have a callback for the audio context component that gives you the internal audio context object, and then you can create your periodic waves or your buffers from that. To get data out of the graph, for analyzer and bytecode filter, you can basically pass a function. When that analyzer gets initialized, it will be given, the function will be called with this proxy object, and that has all the methods you need to call whenever you want. Audio worklet, it's very similar to everything else, except you have to pass the worklet name to the component. Right, and this is very fresh. I've literally built this yesterday into the library because I finally came up with how I can do it. But I created this kind of abstract R extensible class, which you can actually use to create your own subgraphs. And this class could then be exported, and it could be, you could basically share your subgraphs on NPM, for instance, so people could import this delay line into their own projects. So this has not actually been published yet, but it's going to be later today or tomorrow. It is on GitHub already. Right, so just to quickly show you some code examples. So in the code, in the repository, I've made this kind of demo page, which you can run by npm run dev. And it looks something like this. I'm going to turn on the volume. But the example I'm going to show you is courtesy of a colleague of mine. There's a lot of people at BBC R&D working with binaural audio, and they use a subgraph called a gain matrix. So what happens there, let me just try this. So there's a recording playing here from buffer source, and we have 4 gain nodes, and each gain node, so 2 and 2 gain nodes correspond to each channel of this stereo recording, and then each gain node is connected to either the same channel or the other channel. So you get this kind of matrix configuration, and that's what they use for mixing binaural sound. So you can see that here we've got this kind of HTML-based view of our graph, and then I can use these input fields to hopefully, is this going to do something? Right, so this kind of, it's only a stereo recording, so it's actually not that useful. But you see what I mean. And so the code for this is actually now using the kind of extensibility that I showed earlier. So let me just see if I can make this a bit bigger. Right, so in this code, I'm importing all my stuff, and then I create a gain matrix class that extends this R extensible. And then I have some gains with the actual gain values in an array of arrays. And then I'm just basically mapping over them here. And for each of them, I get like a row, and that's a pipeline which contains a gain node and an input element. And that input element is then linked to the gain node. So I can just take that chunk and I could put it up on NPM, and it's going to work for everyone. And so down here, I then have an R-split channels, which wraps the whole thing, and that kind of distributes the rows for different channels of the input. And then down here, because it's an example, I've got a piece of HTML explaining what it is. And I'm just passing my gain matrix class here. And this is it. Similarly, I have a delay line example, which, if we go here, no, that's not the one. Custom node, right. And again, I've just created a custom RAudio element called delay line, render the graph, and stick it in here. And I can pass the props to it as well. So it kind of acts as a normal web audio node almost. So yeah, and lastly, I just want to talk to you about the kind of evaluation of this library. So one of my worries was always performance, because React actually is a very complex system and a complex framework, and there's a lot going on when you make a change. So I did a little test, which I don't think it's quite sufficient yet to fully assess the performance penalties of doing this all in React. But so what I did was basically I just called start with a 0 on an oscillator and a buffer source, and I also tried it with ending the playback of these two nodes, and measured when the on-ended, I think, is it on-ended? Callback was fired. And so you can see that the average latency was fairly significant. I know that normally you wouldn't necessarily need to start the buffer source immediately, but for interactive applications in React, you might need that. I haven't had a way of, or I haven't tried assessing how much of it is actually in the React internals and how much of it is just the UI latency. But it's definitely a cause for concern, especially compared to the native latencies. So in the future, I'd like to do proper performance testing. I would like to also see if many people can use this library and battle test it in their own applications, and see what kind of shortcomings they'd find in it. And lastly, I want to think more about kind of scheduling and dealing with sequential stuff and data, and just making it easier for people to do scheduling, because currently the kind of prop system isn't, I think, as robust as it should be. So yeah, that's it for me. Our audio is available on GitHub under the BBC organizational account, and feel free to follow me on Twitter if you have any questions. Thank you very much.
Thank you. I have a few questions here. So, how are the underlying audio nodes actually connected? Does the pipeline component gets ref to all of its children?
Wait, do you mean the HTML components or everything inside?
I think who answered? Who asked the question?
Right, yeah. So in React, you get, if you pass children to a component, you get a list of the children. But there are some tricky things around that, which I don't have time to talk about really, but you can't actually connect, can't actually access the internal data of the child, but you do get a list of them, and then you can give them these functions. So I actually have this kind of internal repository of nodes, and then I'm using those to create the functions. It's quite complex, but I'm happy to chat about it later.
We have a bit of time because there are only 4 papers today, so don't need to rush a lot. So there's another question. Is that an equivalent to the bus component you showed in that other react-webaudio library?
To the which one?
Bus equivalent to the bus component.
Right. Not at the moment. I'd be interested to see if that's something that people would like to have in this library. I kind of wanted to have a very direct mapping to how you actually create the graph. So the bus is almost like a one level above that. But if that's something that would be useful, then I'd be happy to implement it.
Next question. Can you also connect to audio params or only to other nodes?
Oh yeah, I did actually have an example in there, but I didn't point it out. So you can, if you have a pipeline and there's, say, an oscillator and a gain node, you can, on the oscillator, you can say connect to param and give it the name of the parameter, and it will actually connect to the parameter.
Last question. Can you elaborate a bit on your ideas for the timing scheduling components?
It's very vague at this point, but I'm just wary of the fact that like passing the, like basically the way you would currently kill an oscillator when you want it to stop playing is you would either you would basically remove the start prop, which is I don't think that's very intuitive. It's like what you really want to do is tell it to stop in a more explicit way, but I'd have to think about it. I don't really know. But if you have any ideas, I'd really appreciate it.
Thank you again.
Thank you very much.
Let's see.